In this video, we'll be applying the rules of properties of convergent series. In this video, we're going to have to work through the steps of how to manipulate this particular series so it is something that we can either A, concludes that it is convergent, or B, concludes that it is divergent. Again, the way that we're going to do this is by utilizing the rules that we've identified in the last video. So the first thing we're going to identify is the fact that there's a series here minus another series here. Now, if this thing is convergent and this thing separately is convergent, then technically I can say that this thing is going to be equal to the summation of k equals 1 to infinity of 5 times 2/3 k minus the summation of k equals 1 to infinity of 7 to the power of k in the denominator and 2 to the power of k minus 1 in the numerator. So now I have two separate series, and again, assuming that this one converges and this one converges, well then this original one will also converge. So the next step that I'm going to do here is I'm going to go ahead and try and manipulate each piece. Well, I'm going to go ahead and just clarify this one right now, right off the bat, that I know for a fact that this thing is convergent. And the reason why I know it's convergent is because it's a geometric series. This is hopefully coming back from previous videos you've watched, such that r is absolutely less than 1. Given that that r value is 2/3 and not something that, again, is larger than a fraction of 1, then we can argue that this thing is actually going to be convergent. Now, let's recall what it converges to. I know that's going to converge to a over 1 minus r. More importantly, such that the a value is not this 5 necessarily, it's what happens when I plug in my first term value. So when I plug in k equals 1, that's going to be my a. So I know that this term right here is a convergent series because it's a geometric series with r less than 1, and it's going to converge to 10/3 divided by 1 minus my r value being the value to the power of k, 2/3. So this I can simplify, but I know that for a fact this thing is convergent, and it's convergent to this value. Minus. Let's go ahead and take a look at this one next, and it might be important for us to actually manipulate this one a little bit further. Now, you might think that, hey, this looks actually kind of like it's close to something geometric, but we have to make sure that we can write it exactly as something geometric before I can actually start using those rules. Now, I'm going to rewrite the summation series because I'm not done manipulating this, and I'm going to go ahead and skip writing those bounds because I know that the bounds on this thing are from 1 to infinity again, so I don't need to write those. If it's starting at 2, I should probably write those, but 1 to infinity, leaving out the bounds implies that those are the same bounds. Now, the way that I can manipulate this, and I'm going to go ahead and jot it down up here, is this not 2 to the k times 2 to the negative 1? Again, noticing that this is technically 2 to the k minus 1. That power, I can consider them as being added in the exponent, and if they're added in the exponent, then they're multiplied as the same base. So now this piece right here doesn't actually have a k on it, and I can, again, evaluate that negative exponent by moving it to the denominator. So really this is 1/2 times 2 to the power of k is left on top, over 7 to the power of k, which is left on bottom. And again, powers can be distributed over multiplication or division, which means that I can undo that distribution and change it to 2/7 to the power of k. Knowing that this is going from k equals 1 to infinity, I can recognize one more time that this is nothing more than a geometric series, and a geometric series such that my r value is 2/7, which is less than 1. So, one more time, this is a geometric series with r less than 1, absolutely less than 1, and this thing is going to converge to a divided by 1 minus r. My a value is when I plug in 1, so it's going to be 1/2 times 2/7, which is really just going to be 1/7. And my 1 minus my r value being 2/7. This is still minus the 10/3 over 1 minus 2/3, and this provides us with this series converges because I'm allowed to technically pull this 5 out, and I'm allowed to technically pull this 1/2 out, and then evaluate each of these series separately, and then combine their series together. Again, if this whole thing is convergent, then each of these series convergent separately converges to these two pieces separately, and then I can combine like terms. If you'd like to go further with this, this becomes 10/3. I can subtract this. 1 minus 2/3 is really 1/3. Minus over here I have 1/7, and then 1 minus 2/7 is really 5/7. And I'll notice that the fractions all cancel out. I'm left with 10 minus 1/5, which if you're so inclined to do so, I can change this to 50 over 50, or 50 over 5, giving me 45 over 5, and therefore the final answer would be some form of 9. That can't be right, is it? Yes. In that case, again, the steps that we're taking are simply to evaluate and manipulate this setup here. I'm sorry, this is 50 minus 1, so this is 49 over 5. 49 over 5. I knew that was wrong. I don't know why I was thinking of that. But in any case, 50 over 5, 50 minus 1 is 49, 49 over 5 is the evaluation of this series as k goes from 1 to infinity.